All right, today is the 22nd, and these are kinetic energy and gravitational potential energy calculations. All right, so first thing I want to start with is a little before and after picture. So I'm going to have this like a little ledge, and here's some grass, and up here is a ball. And this is, we'll put before. And then for our after picture, we'll have that ball right before it hits the ground. Okay, now that we've drawn that, up here, we know that ball is going to have all gravitational potential energy. And then right before it hits the ground, that has turned into 100% kinetic energy. Now, if the ball were exactly halfway through, it'd be half gravitational, half kinetic. According to the law of conservation of energy, energy can't be created or destroyed. And what that means in this scenario is that the gravitational potential energy has to equal the kinetic energy. So if you're given a problem and they tell you this ball sitting on top of the cliff had 18 joules of gravitational potential energy, how much kinetic energy did it have right before it hit the ground? You know it's got to be 18 joules. Now, when it hits the ground, right, it's just on the ground there. It's got no more kinetic energy, but it wasn't destroyed. And actually, because this is a ball, I'm going to guess it's going to bounce a little bit. So then we're going to have some, well, it'll make a sound. That's acoustic energy. Maybe from hitting, you get a little friction, a little heat energy, and then some elastic energy, and it will bounce back up to kinetic. So it's never destroyed, it's only transformed. Now let's look at, we are going to solve, I believe, 4 problems to practice. The first one, we're going to draw a picture. And this time we have like a rocky cliff over the ocean. And up here, we have Moana. Moana is going to dive into the ocean. So some information that you need to solve this. Moana's mass, 45.5 kilograms. You also need to know the height of the cliff. We'll say that is exactly 10 meters. And the problem we're trying to solve is find Moana's gravitational potential energy, given all this information. Well, we know her mass. We know the height, but we need something else. We need gravity. We're assuming Moana is on Earth, and the gravity is 9.8 meters per second squared. Our formula to solve this that we wrote down yesterday, GPE equals mass times gravity times height. $45.5 times 9.8 times 10 meters. $4,459. And if I combine all those units, kilogram, meter makes meter squared over second squared. And that is the same as saying 4,459 joules. Now with our previous problems, we liked using a formula triangle because we know we're not always just solving for that one main thing. So there is kind of like a, I don't know, alternative formula triangle that we can make work with this formula. Looks like this. All right, so we have GPE equals mass times gravity times height. We can gather that from this. But what if you're solving for mass? How would I read that? Well, I cover it up. Whatever I'm solving for, I'm going to cover it up. And I would then be able to look at this and go, okay, mass is GPE over G times H. And that's how I could use that triangle to figure out the formula for these other things. All right, problem 2. Tie is moving at 3.2 meters per second. And has a mass of 61 kilograms. Find tie's kinetic energy. So we're given a bunch of information here. Velocity is 3.2. Mass is 61. Solve for kinetic energy. Our formula that we wrote down yesterday, kinetic energy is 1/2 of the mass times velocity squared. One half of 61 kilograms times 3.2 meters per second squared. Half of 61 is 30.5. 3.2 squared, 10.24. Making sure to also square the units. I multiply those together. And then it's kilogram meter squared over second squared, which is a joule. So if we look at the energy of Moana and look at the energy of Ty, we can make some conclusions. We know that Ty has more mass. Ty has a mass of 61, Moana has a mass of 45. But Moana has more than 10 times the energy than Ty does. So you can see before Moana hits the water, she is moving a lot faster than Ty was because that energy is so high. All right, problem 3. A truck going 2.6 meters per second has 40,000 joules kinetic energy. Find the mass. This time I'm given velocity. I'm given kinetic energy. And I'm solving for mass. My original formula is Ke equals 1/2 m times v squared. I'm going to rearrange that formula to solve for the variable I want. And the variable I want is m. So to do that, I've got to get rid of the v squared over here. So instead of multiply, I do the opposite, which is divide. So if I divide away the v squared, I get Ke over v squared equals 1/2 of m. Now I want to get rid of the 1/2 and just have m by itself. And to do that, I multiply by 2 on both sides. Now I have this completely rearranged. Some of you, on the other hand, though, you don't like rearranging it like this. You rather plug in numbers and just start to work. That's fine. As long as you show your steps, I don't care which way you do this. 2 times 40,000 divided by 2.6 meters per second squared. 2 times 40,000 is 80,000. 2.6 squared, 6.76. I really want to show you how I got those units. A joule is the same thing as a kilogram, meter squared, second squared. Knowing that, this cancels with this cancels with this, and I'm just left with those kilograms. All right, hang with me. We only have one more. The reason we're going through all these is because typically students have a hard time rearranging equations. And I want to show you how to rearrange anything you could run into. So here's number 4. Find the velocity of a 2 kilogram object with 13 joules of kinetic energy. We're finding velocity, question mark, mass, 2 kilograms, kinetic energy, 13 joules. Original formula, kinetic energy is half of the mass times v squared. My goal here is just to solve for v by itself. Let's completely divide away half the mass. Let's get it out of there. So if we go Ke divided by half mass equals v squared. Now we have to get rid of the squared. And to do that, we do square root on both sides. So I'm going to end up with square root that whole thing, and we've solved for velocity. At 13 joules, half of 2, square root. I just plugged in my numbers from here into the equation. I'm going to solve this step by step. Half of 2 is 1. 13 joules divided by 1 kilogram is 13, leaves you with meters squared over seconds squared. The square root of 13. 3.6. And then the square root will take care of these, and we're left with meters per second. And now we have solved for velocity.